Here we have a SAT math question. Okay, let's go to the information. F of x equals to x negative 10 times x positive 13. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Actually, it's a quadratic function because here the two binomials, linear expressions are multiplied. Okay, now let's write the given quadratic function in standard form, that is ax square positive bx positive c. So this is a standard form of a quadratic expression. Okay, now let me take the given quadratic function as this, that is x negative 10 times x positive 13. So the given quadratic function is in factored form. So our first work is to write this quadratic function in standard form so that you'll be able to find the value of x for which f of x is minimum. Okay, to write this quadratic function in standard form, I have to multiply the two binomials over here. So we can use the FOIL method to multiply the two binomials. That is, first we have to multiply, that is the first terms, x times x will be x square. And now we have to multiply the outer terms, x times positive 13 will be positive 13x. Now I have to multiply the inner terms, negative 10 times x is negative 10x. Now I have to multiply the last terms, negative 10 times positive 13 is negative 130. So then I'm getting f of x equals to x square, and when I combine positive 13x and negative 10x, I'm getting positive 3x negative 130. Okay, now this quadratic function is in standard form, that is f of x equals to ax square positive bx positive c. Okay, whenever we have a quadratic function in this form, its graph will be a vertical parabola, and the parabola may open up or may open down when the parabola is vertical parabola. It depends on the value of a, which is a leading coefficient, that is a coefficient of x square. If the value of a is greater than 0, then the parabola opens up. If the value of a is less than 0, then the parabola opens down. So in our case, what is the value of a? So here the value of a is a coefficient of x square. We don't find any number in front of x square. So then we have to assume there is 1 in front of x square. So that is a equals to 1 in our quadratic function, that is a is greater than 0. Since a is greater than 0, if I sketch parabola for this quadratic function, it will be an open upper parabola. So we'll have a parabola like this. So whenever the parabola opens up, the vertex over here will be the minimum point. So we can write the minimum point as x comma f of x. So vertex is the minimum point of the parabola. So now this minimum point we have to find the value of x. So because the question is asking us to find the value of x for which f of x is minimum. So usually f of x is minimum at the vertex. So f of x is nothing but the y-coordinate. So there is a formula to get the value of the x at the vertex. So when a quadratic function is given in this form, f of x equal to ax square positive bx positive c, the formula to find the x-coordinate of the vertex is x equals to negative b over 2a. Now, when I compare this one and this one, I am getting a equals to 1 and b equals to the coefficient of x3 and c is equal to negative 130. Okay, now let's find the x-coordinate of the vertex, that is x equals to negative, the value of b is 3 and the value 2 times the value of a is 1. So then x equals to negative 3 over 2. So the x-coordinate of the vertex, let me erase x at the x-coordinate of the vertex. So it has to be negative 3 over 2. So when x is equal to negative 3 over 2, so f of x gets its minimum value, that's at the vertex. So the value of x for which f of x is minimum is negative 3 over 2. We find negative 3 over 2 in option D. So the correct answer choice for this one is option D.